next up, what hardships did you overcome to become a professor?
Uh, Hardships. Um, I'm not. I guess there are hardships of a sort. One thing, clearly, to become a professor, becoming a professor and being successful, because one does go through, of course, the different stages of being a professor, of starting as an assistant professor, and to get that job, you will have had to have worked quite hard through college, through graduate school, through postdoctoral work. And then as an assistant professor, you're not sure you're going to have that position the rest of your, be a professor the rest of your life. You have to earn tenure. So you can get all the way to that point and then find that you have to do something else with your life. So that's a great motivation for working hard. Uh, and so that is a time in life where you really devote a lot of your energy and your time to your profession. And so a hardship is that that's also a time in your life when you're having a family. So young children and their needs and demands and the needs of a family. So I would say that that's there's some hardship at the uh, different years of your life have different attributes. I would say in hindsight, the 30s are pretty tough because generally speaking, that's the time when if you're going into academics or really any job, you're working really hard at getting yourself to a certain level in that position. So you're working hard in your job. You're generally speaking still kind of newly married. You're maybe have young children, and maybe you're in your first house, and you have to take care of a house, which has a whole bunch of demands on your time and energy as well. So the 30s are kind of a demanding period, but then in your 30s, you're still pretty young. You have lots of energy, and it takes lots of energy.
What would you say it was what's your advice on how to balance, that personal life and also, maintaining your career?
Yeah. Well, I'll share what worked for me, but I don't think that that's necessarily what works for everyone. I've always been kind of a morning person, and so I'll wake up at 4:30, 5 o'clock, even today, but I have for many, many years. And I'll get a couple of hours work done in the early morning that get me started on my day so that my day is a bit less stressful. Uh, then it's not necessarily the case that you work super long hours each or a few days of the week or something. What I've found it's better to be persistent in your effort. So put in your good 8 to 10 hours of effort each day. And that really builds up over time and you accomplish a lot. I saw some of my colleagues working, being at work many more hours than I, 14, 16 hours a day. They would go back after dinner, or maybe they wouldn't go home for dinner and they'd be there late into the night. But on the occasion that I would come back in, what did I find them doing? Chit-chatting in the hallway about work stuff, but still, it wasn't really work. It wasn't really accomplishing anything of particular importance. So there's a few expressions out there. Work smart, not hard. Put your time into the things that really matter. Or another way to say that is, do you prioritize your schedule or do you schedule your priorities? And I would urge that one should schedule your priorities. So at the end of the day, you've accomplished what's really important to you. I mean, it's all too easy just to kind of be responsive to the different things that have come across your desk. People ask you to be on a committee and do this and do that and do that. You can fritter away your entire day just taking care of things that way. I think it's important to uh, prioritize things that are truly meaningful to what you're trying to accomplish. So I would usually be home, for dinner and stay home with family and kids and have parts of my weekend for weekend activities with family. And so I'm very pleased to say I've been married for over 40 years now and have children that are doing well in their lives and grandchildren as well.
Yeah, that's wonderful. Thank you so much. All right, our next question. What is your advice for current high school students who are interested in pursuing marine biology or really just STEM in general?
Yeah, there are some high schools actually, like here in La Jolla, the high school does offer a course in marine biology, and so if you have the opportunities to take courses in your high school that are on that topic, great. But the fundamentals are really important to get to. So to take your chemistry and physics and math and set yourself up for a good college experience. Um, the other thing to do, though, is that your summers, there are increasing numbers of summer programs for high school students and undergraduate college students to spend their summers in a research experience. UCSD offers that, and we've had a number of high school students come into our labs over the summer and participate in that. And usually it ends the summer. Usually it's about an 8 to 10 week period. Ends with some kind of a symposium. Usually the students will make posters to explain what they've been working on, and then we'll have a symposium where they present their posters to the folks that are attending, which usually includes some parents and siblings and whatnot. And it's a pretty fun time. So making use of your summers to start to build some depth of experience is a, a bit of advice I would give.
Hmm. Absolutely. Yeah, thank you. Yeah, there's definitely so much stuff out there, as a sophomore myself, I'm like starting to get into all of that jazz with summer programs and all that. Yeah, there's definitely so many opportunities out there for everyone.
Oh, great.
Yeah, and our next couple of questions are going to be more career focused. So first up, what are you currently researching?
So I'm closing in on 70. So I'm getting at the final stages of my career. And it's fun to participate in this podcast or a Zoom call to just share some of the experiences of that. Um, so uh, at the present time, we're a little bit smaller laboratory. I have, I think, 12 people that work in my lab. So there are several undergraduate students, a master's student. I stopped taking PhD students a couple of years ago because they are usually about a 5 year commitment, and I wanted to have some more freedom in the future. So working with these shorter term students and then so-called postdocs, these are people that have already earned their PhDs. And so there's 4 postdocs in the group and then a laboratory technician. And so we're working on a few different projects. So one project that's really got my great interest and enthusiasm is several years ago, we went scuba diving in the island country of Curacao in the Southern Caribbean. And there we found some cyanobacterial filaments. They're like threads or hair that grow up off the seafloor. Uh, but they're actually bacteria, but they're giant bacteria that you can see with your naked eye and collect by hand. And we've come to focus on these because they're very rich with their unusual chemicals they make that some have very, very potent biological activities. So this one from Curacao indeed the extract of it was very potent in an anti-cancer assay. And we isolated the active compound and used NMR and mass spectrometry to figure out what that structure was, the arrangement of carbon atoms and hydrogens and oxygen atoms to make up the molecule. And it's a new molecule that had never been seen before. And so we called it carmaphycin after the Carmabi research station that's present there in Curacao. Uh, going forward, though, we found that the same molecule was very active in killing some parasites like malaria and trichomonas and trypanosoma, as I mentioned previously. And the molecule is not so very complex that actually there's a team of about 4 people in my lab that are working on doing organic synthesis, mixing different chemical reagents together to make that molecule and make analog structures, things that are similar to that original natural product. And what we've found is that as we modify things a little bit, we can get great selectivity to one of those targets over another. For instance, we have made an analog that's 2,500-fold selective for the malaria parasite over human cells. And so that's a great selectivity, and it's attracted a lot of interest from the Department of Defense here in the United States, where we get some funding, and also from the Bill and Melinda Gates Foundation that gives us some money for that work. So I am hopeful we're really going to come up with a new anti-malarial drug as a result of these efforts, and so we're pushing forward on that.
Mhm.
Another area that I'm very excited about is UCSD and many universities, but UCSD I think has a special aspect that people in different laboratories collaborate with each other and talk in really productive ways. So for about the last 5 years, we've been collaborating with a computer scientist that's one of the, I think, leaders in the field of deep convolutional neural networks to automatically annotate and describe images, so image recognition. So I've been learning some computer science, and we've been teaching him some organic chemistry and natural products chemistry. He and his students, and I and my students. And as a result, we're creating tools that can look at the spectra and automatically tell us what kind of molecule it is, or it can look at the structure of an organic compound and tell us whether it's going to be cancer cell toxic, whether it has some anti-cancer potential. So these are, sort of AI tools based on deep learning, and I think this is an exciting frontier. I'm really fascinated by the power of these algorithms.
Yeah, it's a lot of different fields coming together to make new things, isn't it?
It is,
Mhm.
and that's what, as if you're a younger person like yourself, you're looking like, oh boy, how could he be doing this for close to 50 years? Since graduating college, going into graduate school at 21, I'm now close to 70, so close to 50 years. Um, I'm stimulated and excited every day because it involves so many different fields of chemistry and computer science and pharmacology and natural history and spectroscopy. Uh, my day is hugely varied and stimulating.
Yeah, that's wonderful. Thank you. Yeah, and speaking of which, what does a day in the lab
Uh,
look like for you?
well, a day in the lab for me is a day where I'm actually not going into the lab much these days. It's really my students and other people working in the labs that are in the lab. But a day in my life, what does it look like? As I said earlier, I wake up pretty early, maybe, someplace around 5, and I like to catch up on some emails, some writing projects, some things of that sort to maybe 7. Then I usually get some exercise, have some breakfast with my wife, and get into the labs here by maybe 8:30 or 9 o'clock in the morning. And the life of a professor, as I indicated, it's highly varied. I may spend a half an hour or 45 minutes talking with one student or another, or a person in my lab about their projects. We collaborate with many different people and the computer scientists, but other people as well and other labs. So I'm probably on Zoom once or twice a day with other people in a meeting um, to discuss our research projects. And then writing up papers, writing up the research, and writing grant proposals. So a big part of my day is writing and thinking. I don't find it boring by any means. It's to uh, to write up science can be challenging to really get the precision in your wording so that you convey the exact meaning that you want to is can be challenging and so it can be fun to write the perfect sentence if there is such a one. Um, yeah, so it's a mix of science and people and computer work.
Mhm.
And yeah, I'll usually finish up 5:30 to 6:30 someplace in there and head home. And as it's just my wife and I now, as our children are out of the household, we both like to cook, and we've come to a good arrangement that we alternate days of cooking. So that's probably where I do my major chemistry is in the kitchen.
I love that. Thank you. Yeah. All right. So next up, what is your favorite part about teaching at UCSD?
Yeah. Well, let me just share that I've come to really enjoy teaching and the teaching component of my job. Uh, as I see that if I put in the effort to really prepare the material that I'm going to talk about or that we're going to have discussions about, or if I'm going to try and ask some probing questions, if I really thought about that, then it turns out to be a very gratifying experience. It responds very much to effort. The more effort in, the more pleasure out, as it were. And what is that pleasure? It's the pleasure of feeling like you've really communicated clearly, that you've opened eyes on a topic, understanding, and occasionally even that you've maybe inspired a student in the classroom to read more, investigate a topic, or get excited by the topic and want to do that in their lives. So let me relate an experience that's happened over the last couple of years. We all went through an absolutely amazingly, generally terrible, but sometimes with silver linings, experience in the COVID pandemic. And students coming into the university a year ago, they had been going through the last couple of years of their high school in COVID, so they were remote and at home for the most part, and it was a really different experience. So starting last year, where we had classes in person, last year or maybe it was before that. I teach a class not every year, but about every other year on to a freshman seminar class in the fall quarter. So these are students that are coming into their very first experience in the university system. And these freshman seminars are to complement sort of the large lecture style classroom situations where it's a 1 unit seminar. I teach it on drugs from the sea. They limit it to 20 students. And it's really an opportunity to have more discussions and have a different kind of experience in the university. And it's just been so gratifying to see the students the last couple of years coming into that have just been hungry. You can see it. It's a palpable hunger to have contact with one another, to engage in dialogue in an in-person situation. And as a result, several of those students not only was it really fun during the quarter, but they asked if they could come into the lab and do some research. And so that's a couple of the undergraduate students in my lab right now. It's something during the course of that quarter, I encourage all of the students to look, do well in your classes. That's the core of the university experience. But the university has so much more to offer. So to engage in research, if that's your experience and desire, or in the sports or in clubs or these other kinds of activities that are present in the university, it's uh, I think really important to do those in addition to do well in your classroom.
Hmm. Yeah, so like say if an undergrad wanted to get involved in doing some research, how would you recommend them go about doing so?
Yeah, that's a really good question to ask. I mean, first off is, I mean, students sign up for these freshman seminars, and I don't think they're required to do them. So looking for those opportunities that are going to broaden your knowledge and bring you into contact with different kinds of people like myself and the other interested students in the classroom. That's one step. But I would say thinking about what your interests are and then researching it on your own. Students now have great computer skills and all the information is at your fingertips. So find out, who's doing research in a particular topic at your university, and then research them some more. And maybe you won't understand everything they're doing, but look up some of their papers and come to understand, well, okay, I don't know what they're doing with malaria, but they're doing something with malaria. And I know you can look at Wikipedia and read a Wikipedia page and come to know something about malaria and how it's devastating for children under 5 are the most strongly afflicted, and many die every year from malaria. Um, so do your homework is what I'm saying. And as a result of that, then make contact with a person or some people and express your interest in their topic and their interest, and that you're looking for that experience outside of the classroom, that you have a passion for anti-malarial research and would love to do whatever you can uh, in their laboratory. It's helpful if students have organized their course schedule in ways that they have blocks of time that make it reasonable for them to go into a laboratory. It's difficult to go into a laboratory for an hour or 2 or 3 and get very much accomplished. So if you have Tuesdays and Thursdays generally free, or at least, like a block of 5 hours free, then it becomes reasonable that you have enough time to actually make some meaningful progress and contribute to a laboratory effort.
Yep, got it. Hmm.
Um, I mean, realize also that professors like to work with students. We really do. So don't feel shy to express your interest. And if you ever got rebuffed, uh, that's on them, not on you. Um, Yeah, and I used the expression previously as it related to another topic, but one has to be persistent. You can't give up if you get set back on a rejection or something along the way. You just pick yourself up and keep going, and success happens as a result of that persistence. I've seen it happen over and over again.
Hmm. Great. Thank you so much for that advice. All right, I believe this is our last question. Which project or achievement from your career leading up to now are you the most proud of?
Oh, well, maybe I'll give you two answers, because one is deeply satisfying to me, uh, but I think you're looking for a different kind of an answer. I would say that the thing I'm most proud of at this point in time are my students, the students that have come through my laboratory, and to see that they have evolved from maybe coming in, particularly my PhD students and some postdocs, so at the higher levels of training. They've come in maybe a little uncertain. Was this really the right field for them? Was maybe they, yeah, just the uncertainty, and to see that they develop confidence, that they have some successes, and then they move on to sort of the next stage in their lives and go on to make tremendous contributions of their own. About half of my students are now professors at other universities, and another big portion of them are in the private sector. Some have started companies. Some work in large governmental or non-governmental organizations, but they're all doing, really useful, good things for their lives, and I think have satisfying lives. So that gives me great pride and pleasure to have contributed in that way. But that's a kind of more general thing. This project that we're working on right now with its anti-malarial potential is super exciting, and that's a general. There's been a lot of parts to that, and I'm proud of all the things we've accomplished there. There was a molecule that we discovered in 1993 that was a really significant discovery by my lab, and one that I worked on. I was still working in the laboratory at that point. It was a small molecule that was super toxic to cancer cells, and we just defined its molecular structure. It was a new molecule. It came from that same island of Curacao in the Caribbean, so we called it Curacin A after Curacao, hoping that it would also cure something. So it was a kind of fun name. That molecule, we've probably published 50 scientific papers on that molecule. Everything from its structure to its synthesis to its biosynthesis, that is how the cyanobacteria makes it, to the genes that are involved, to the mechanisms of some of the enzymes that do very unusual transformations in creating that molecule, to the nature of the organism that makes it. We, in fact, renamed it because it was misclassified in the literature. That would be one of a few molecules that I can point to that are things I'm very, very proud of.
Mm-hmm. Yeah, definitely. Yeah, I wanted to just go back a little bit to the first part of your answer. What do you think was the part of, those students' experience at UCSD that really made the difference of, turning them from like students to real life scientists?
Oh, that's a good question. Um, I have seen not every student exactly the same way, but many have a certain particular arc. Uh, if you're maybe familiar with the concept of a story arc, that you have a hook that starts a story, you have a development of a theme, there's a resolution of the theme, and you get to the end of the story, and there's some kind of a twist at the end. That's called the story arc. I've seen a graduate student arc, where a student will come in and be enthusiastic but kind of uncertain. They'll slowly build their knowledge of the tools and techniques and the underlying information that's needed in an area in order to do research in it. And that will come with some setbacks and, two steps forward, one back kind of concept for a period of time. And then I've seen this with many students. They get to a certain point and they get over a hump. And it's where there's a certain level of confidence that they know what they know. They know that they know how to solve a molecular structure and what that means. and what are, various types of pharmacology and what that might be useful for in terms of medical application. So it's getting to a certain level of knowledge, and that they get over the hump, and then usually that's at about year, someplace between year and 3 and 4. And so then after that, they have another year of really productive time as a PhD student. So uh, I'm not sure I exactly answered your question, but I thought that might be useful. That there comes a period of some struggle and uncertainty, uh, and then you just kind of have to go with a bit of faith that you're going to get someplace. But it's my experience that students do are successful from that persistent effort, and they get to a certain point where they become knowledgeable. There is this I can't remember the author. That's terrible. A very popular author who's written on what makes for successful people, and took the example, I think, of Bill Gates, that he had unlimited access to a computer when computers were like brand new things, in the garage of a neighbor or something like that, and that it's estimated he spent 10,000 hours uh, playing on this computer, and as a result developed this level of expertise with computers, and that you could look in various fields and identify that it takes kind of regularly something around 10,000 hours to really develop expertise. So if you look at a PhD program, and it's maybe you're working maybe 250 days of the year, and maybe you're working 10 hours a day, so 2,500 hours a year for about 4 years, and you become an expert. And yeah, I think that's a reasonable equation.
Hmm. Yeah, that's a fantastic answer. Thank you so much. Um, yeah, it's definitely super important about staying consistent. Yeah. Um, all right, so yeah, those are all of the questions I had for you today. Yeah, thank you so much, Professor Gerwick, for your time today. Yeah, thank you so much for sitting down and having this conversation with me.
Well, very good luck to you and your group. Love the name of your group. That's a bit of fun there, and hope maybe some of the words I've had today will serve as a little bit of guidance or inspiration to a few of you. So good luck to you all.